What is then Red Hat Storage Server? First of all, it's a scale-out system, scale-out network attached storage, a NAS system. It's a software-only appliance, which means you get a DVD and the Red Hat server, a storage server is on it. You can deploy that on commodity x86 64-bit hardware systems, but also on supported cloud systems, like for instance Amazon. I'll get back to that later in more detail. You also see something like UFO storage, Unified File and Object Access. This means you can access it with your files, like a NAS system, but also like object storage. So you have two different ways of accessing the data. And it's mostly, like I said before, for unstructured data, not for database data, it's just unstructured data. Okay, well, how is it built? First of all, we are using RHEL, Red Hat Enterprise Linux, as a base. Then within the package GlusterFS, is anyone familiar with GlusterFS already, has worked with it? Okay, so it's a software component from the community, which enables you to create clustered storage. And we use the XFS file system for certain reasons, mostly for stability and also for performance, which is at the moment the only supported file system. If you use the Gluster Community Edition, you can use several sorts of file systems, but in Red Hat Storage, XFS is the only supported file system at this moment. Well, all of those three components together are put into an ISO image, which can be used on premises. So you have a server, a hardware server, you put the image on, and then that's a so-called brick for your storage environment. You can also have an Amazon machine image, which enables you to use disk storage in the cloud, which is offered by Amazon Elastic Block Storage. But we'll get back to that later. So, what is actually Red Hat Storage and who provides what? At the customer side, the customer provides a server. We have certain brands and which are all supported, like HP, Dell servers, also Supermicro, even Cisco servers. Or you use a virtual server, VMware vSphere 5 is supported, and also RHEV, of course. And you can put on the ISO image, also the appliance for your storage, and use VMDK disks as your storage provider. What Red Hat delivers is, like the picture before, Red Hat Enterprise Linux, XFS and GlusterFS, and also a management station built within that ISO. As a matter of fact, you don't have a separate management station. The management can be done from every single node which is a member of the cluster. Okay. Well, let's have a little bit deeper look into that. First of all, we have the RHEL platform, the hardware platform with its disks, network device, etc. On top of that, we always use logical volume management, LVM, which is mandatory at Red Hat Storage. And that is because you add flexibility, and which empowers you to scale up and scale out later. On top of that, we have a local file system and the XFS file system, which is the file system to be used as a storage brick. On top of that, we have the Gluster layer, and on top of Gluster, we use certain translators. Like a translator is a a protocol to talk to the storage. That could be NFS. Fuse is in fact the Gluster file system. It's also called Fuse. We get back to that later. And you can also access it by SIFs. This is a NAS appliance. And Swift, which is used in OpenStack. So that's in a little picture how the whole thing is built up. What you see here is, for instance, volume snapshot, which is not supported at this moment in Red Hat Storage, but which will become in later, used by the LVM, I suppose. Well, how is it built? We have, first of all, we have a server, a hardware server. We put the image on it, and then we create a brick. And what's a brick? A brick is a file system with the XFS file system on it, and it's then called a brick. And you have several bricks which are together creating a volume. I'll show you that later in the technical demo, so you have some more idea how it exactly works. So just to keep it simple, server. On the server we create bricks, and out of those bricks we create volumes in the end, and we present them, serve them out on SIFs, NFS, or Fuse. Fuse is the same as GlusterFS. About those volumes, we have just 3 simple types of volumes. First of all, distributed volume, which is the default volume. And a distributed volume can be expanded. That's what makes the product scalable. So you can grow your volumes, and as a matter of fact, technically spoken, there is no exact limit on that. We do have limits, but that are limits that are applied by the support. They do support until a certain amount, which is at the moment 64 petabyte. So we still can use some, but the other possibility is a replicated volume. When you have 2 or more bricks, you can replicate all the data on those bricks. You can save your data 2 times, 4 times, whatever you want. That's in a replicated volume, which has nothing to do with the DR volume on some other side. So we're talking, when we talk about a replicated volume, we talk about a replicated data within your cluster. There is some other possibility, which is called geo-replication, which enables you to replicate asynchronous your data to some other cluster environment. But that's another thing than replicated. It's a little confusing, maybe. But, and then finally we have the striped volume, which means that files are cut up in pieces and they are striped throughout the bricks. Why do you want to have that? Because if you need a lot of read performance, you have a lot of spindles which provide the data when you use a striped volume. And then you can mix up all those types. You can have a distributed replicated volume, you can have a replicated striped volume, you can use them all together, but we will get to that later. Every possible combination of those 3 basic types are possible. First of all, the distributed file system, to visualize it. We put on files. File number 1 is landing on brick number 1. File number 2 also, and file number 3 goes on the other brick, and then it expands all the time. You can add bricks as much as you want. So you can start off with a small amount of storage and can grow that if you need to. You can add bricks, you can do that online, you can expand your file system. So that's the distributed file system, which is used for scalability. The other one, the replicated file system. This is a replica of two nodes, which causes the files to appear on both bricks. But as a client, we don't deal with these bricks. We talk to Gluster, and it's transparent for us. We don't have to worry about where our data lands. This is done below the Gluster layer. This replicates it onto more disk spindles or bricks. And then the third one, like discussed earlier, this is the striped volume. And this is one single file cut up in 6 pieces, and those are spread across all available bricks. In this example we have just 2 bricks, but you can imagine you could have maybe 4 or 8 bricks. And the more bricks you have, the more disk spindles you have, which enables you with more performance for read. This has specific meanings. Then we have distributed striped, just to keep it simple. Distributed for scalability, and striped for the performance. So that's a combination of 2 basic volumes. You can also have distributed replicated. Then you have your data replicated onto more bricks, and you also are scalable because you can add all the time. It's a little bit hard to explain for me in English, but I hope you understand. When do you use this? You use this where you need scalability and where you also have a high critical level on your data. You don't want to lose data and you want performance. And mostly for read performance this should be used. Then another example, distributed, striped, replicated. It's 3 times word count. These are striped volumes, striped several spindles, also replicated and also distributed, again for scalability. So distributed scalability, striped for performance and replicated for security. Just to be sure that you have your data if something happens with a low-cost disk, for example. Where is this used? In environments with Hadoop, in example, where a lot of processing takes place. MapReduce, also something where this should be used. So it's not just for a file store, but for specific applications like Hadoop storage. Then in the end, replicated striped, that's another performance one. Also used in Hadoop environments. And Hadoop is the handling of a lot of data, so-called big data, where, I'll give you an example. You have, for instance, an American post company who has 10,000s of lorries driving around cities, and they are collecting a lot of data. Where is it driving? How fast is the driver driving? Where is he at the moment? What is his load? What has he done yet? What has he still to be done? And all this data is collected, but not from only that one driver, but from 10,000s of them. And that is in MapReduce and Hadoop environments, where there is a lot of I/O performance requested. There are this kind of volumes used.
I'm a little bit confused what the difference is with the RHEV 1, with server 1, what the difference is within the software rate there.
Okay, well, actually, we don't talk about rates.
But I'm looking at what the functional difference is between the brick combination on one server and a software rate, which is kindly, I think, doing the same thing.
Yeah, correct. That was also one of the things I was wondering about in the beginning. But in this case, you can add servers all the time, and every time you add a server, you add CPU, you add performance, and also disk capacity.
I can do it with the replication as well. So
Yeah.
I just add another server and I do the same thing. There's no difference.
Okay, but this is one single namespace where you're working with. You can add servers all the time, but we don't use any RAID or thing. That's a level below the file system. So
I understand that it's a level below the file system, but I just from the outside I do not see the difference between two. So I see an extra layer, which I do not see to add any functionality currently.
okay.
I guess the question actually is, so instead of wasting disks on RAID implementation, should we add another brick to it or something? Or what does Reddit recommend for these kind of systems? To use RAID or not use RAID at all?
Yes, indeed, use RAID, but we also use JBOSS. So it basically doesn't matter. But if you use a distributed volume, and which is not protected, you can grow the volume within your Gluster namespace, but the storage below can be JBOSS if you don't use any RAID protection. And then if one disk suffers or whatever, then you have a problem. So therefore, it should be recommended to use RAID storage below, or have some other solution to.
So in other words, you're saying you're not trusting replication of Gluster, then because you can do the same replication, but you normally do for RAID, you can have Gluster do it.
Yes. Yeah.
Still, you recommend using RAID drives?
That depends on the situation, what you are building. If you use just one server, one or two servers, and you have distributed volumes on it, then we would recommend to use RAID storage. But you can also have a situation that you have, for instance, a server which you are filling up with JBOSS disks, where you let Red Hat do the handling of the disks. And it depends on the kind of volume you are creating. It's a little bit confusing, but you always should, in that case, use a replicated volume in order to have your data stored.
Basically what you're saying is that the replicated volume, you can expand beyond the RAID area you have on one single server, because if you expand beyond that, you still have replication, which you don't have with RAID anymore.
Yeah, I think so. Yeah. Yeah, it's a little bit hard to explain in English, but we can eventually. Yeah. Okay. Well, what can be stored in RHS, in Red Hat storage? What we're storing are files and folders. For instance, documents, photos, videos, images, etc. Non-database files. I say it again because there's a lot of confusion about it. We don't do database data, that's another solution. This is pure file data, unstructured data also called. Big data, I gave some little example about it before. This could be all kind of metadata or telemetrics or things like that, which you can store on that. And also object data. Object data is maybe anyone uses Google Docs or something like that. This is also object based. And that also can be done in Red Hat storage. Well, how do you get access to your data? First of all, we have the storage nodes on this side above the GlusterFS volume, which provides you with a single namespace, a single global namespace. So it doesn't matter where the data resides, you always deal with a single namespace. And you connect to that namespace by CIFS, for instance, Windows, by Linux clients, and that can use Fuse FS, GlusterFS or NFS to access the data. In this below picture, you also see the DR solution called geo-replication. If you have a replicated pair here, it's synchronous replicated. And geo-replication is asynchronous. It can be at another location or another part of the country where you have a...
Any limitation on that?
On the asynchronous, no, you don't have limitations. But on the synchronous one, it has to be on the same site. Okay, and then the data management of your data is all done by Gluster. So you don't have to worry about it. If you have a distributed, replicated, or some volume, it doesn't matter. It's transparent for the end user. It just stores away its files and don't have to worry what volume, where is my data going. It's all managed by Gluster. They are seeing it as just one volume, all this. Then we have this slide about metadata and data management. Red Hat storage requires no separate management server. That is the case in most of the current storage systems. You always have a management station where you manage your system, where you manage the metadata. Red Hat doesn't have that. Therefore, we don't have a single point of failure. We don't have a limitation by growing. All storage nodes have a built-in algorithm. When a file passes through, there's a sort of checksum is made, and therefore it's known where it is and where it resides. All native clients, and then we mean the GlusterFS client, have also the same algorithm built in, so that they can pre-calculate it on the client in order to speed it up. If you don't have the native client, then the server handles this metadata thing, this checksumming and things like that. It's done on the server where it accesses the Gluster file system. Files are placed on a brick in the cluster based on this calculation. It's called elastic hash storage. How can a deployment scenario look like? First of all, the most common one is the on-premise data center. That's on the data center itself, on your site. There you can build your storage cluster. You can also create a private cloud with it. So you can. This means you can have a storage cluster on another location or in a data center and build your private cloud combined with the on-premise storage. And you can also use the public cloud. For instance, the Amazon Web Services, they have this S3 storage. I don't know if anyone is familiar with that, but as a matter of fact, it is a storage system you can buy for cloud users, for cloud usage, and the image, the Red Hat storage image, can communicate with this storage, and you can build it into your cluster. Well, what is this storage appliance? It's mostly used for unstructured file data, as we discussed before. It's scalable, it scales linearly and non-disruptively, which means you don't have to go down. You can expand your storage as needed. When you add systems, you also add performance, because you add CPU and you also add memory capacity, and you can scale to petabytes and beyond. You can deploy it almost anywhere. You can even use multi-tenancy. This means that you can have several customers on it which don't see each other. It's also high available by making use of the replica and the geo-replication. And you can deploy it on commodity hardware, so on just normal x86 servers like you're probably already using. With the system, you can, first of all, you can scale up, which means that you can add disk space, just like you did when you added disk shelves to a storage system, which is scaling up. And because you are using LVM on below, you can all scale up. Well, where's the limit? And on the other hand, you can scale out. And when you scale out, you are adding systems, you are adding performance capacity and availability. So, as a matter of fact, you can almost create an unlimited storage system for your file data. Again, the geo-replication, which is asynchronous, to have your data on several sites. Then you also have the virtual storage appliance, which talks with Elastic Cloud, Elastic Block Storage on Amazon. Works exactly the same as the on-premises version, but then in the cloud. And you can also create a combination of both, where you have, for instance, your private cloud, your on-site on-premises cluster replicated to public cloud, and have your data on several spots at the same time. And also do business with this global namespace. It doesn't matter where the data resides, you can always reach it.